Repetitive tasks are boring. Even worse, some GUI tasks, like skipping ads, are tedious and disruptive. Let's make an autopilot that does the task for us. We're clearly not alone in searching the internet for advice and tricks to save some effort in the long term. In this project, we help a person easily bottle a GUI task so that it can be applied repeatedly in the future. With our system, a non-programming user demonstrates the desktop software task by performing it once, and then answering follow-up queries posed by our system. For example, to make a slide presentation out of a folder full of JPEGs, the user shows our system how to make one JPEG into one new slide in the deck. After asking the user some questions, the system is ready and can automatically complete the task by making slides out of all the remaining photos. Our system has 3 phases: demonstration, teaching, and running. As an example, let's switch the OS to high contrast mode. The user acts as instructor, simply demonstrating part of the task while being recorded. Our custom-made sniffer captures on-screen mouse events and key presses. At the teaching phase, the system asks questions if visual patterns or any looping procedures are ambiguous. The user, now acting as a teacher, answers, tagging further positive examples and spatial supporters that let the system generalize what the instructor demonstrated. Finally, when someone triggers the task, it runs automatically. The end user can request the task explicitly, such as through a voice command, or the task can trigger whenever a monitoring task detects specific scenarios. Here we compare to Sikuli Slides, on the left, the only viable baseline for our system. After demonstrating the task, their users check and edit a slide summary of steps, fixing misclassifications and omissions. On the right, our system actively requests help only in parts of the task that need it. Our users found that this saved them time. Also, our system supports more elaborate tasks. Here are some examples of our system in action. The user in this scenario wants just the root PDF names from this folder to be listed as successive entries in a spreadsheet. Only the middle part of the task will be looped, so the user flags this with a keyboard shortcut. When the system asks the teacher for help, it's checking that all the PDFs are detected and why pasting happened at specific locations in the spreadsheet. Now the task runs automatically. It's important to detect actions based on visual feedback in the GUI because many apps, especially on mobile devices, don't let the OS reveal their events. We also have examples that didn't use our key sniffer, but instead ingested a standard screencast video as posted online when people make video tutorials. This linear task shows a use case where we may want to regression test a remote mobile phone or computer. Here we'll use TeamViewer, which lets people and our autopilot connect to the remote device through a username and password, which are stored in a Microsoft Excel file. This is quite a complex scenario. The task involves switching between 3 different applications and 8 different screens. The scenario starts by working through an Excel file that lists paper titles that should be cited. Next, we use Google Scholar to look for the BibTeX for each paper, and then merge all the entries into one single BibTeX file using the Notepad program. Thank you for watching.